Hi everyone, this is a second part of a two-part video around farming versus black box mechanics for gamification design. So in the first video, I was showing how farming mechanics will create behavior, extinction of the behavior, and will make you feel like you're working more than you're playing, and you will create a hedonic adaptation which will lower your dopamine spikes and you will not feel like you're playing anymore after a couple of runs of the same game. Now, we're going to be looking here is how a black box creates a more interesting game scenario. And how does this work? The last time I told you that the formula for farming was the behavior creates a reward. But when you have a black box, you have a game mechanic that actually creates some level of uncertainty. And this is important. What we're going to talk about here is a concept that we will work more on the future. That's the uncertainty principle. Certainty. And this concept is really important because this is what creates replayability in a game. So what we're going to try to do is simulate what will happen in a black box game. So to create a black box, you need to create some uncertainty. So we will introduce player number 2. And this player number 2 will have, let's say, 4 tokens, but we'll show them in green to actually show what will happen with each player in the same system. So what we're going to do is bringing another opponent, another human opponent, we create uncertainty because they cannot figure out what they will do. For example, in things like the prisoner dilemma, you can see that this is happening. So what you will try to do is create some basic scenarios, some rules within the mechanics that will make you not be able to optimize your reward that easily. You will have to be more strategic in gameplay. So let's say you have the same behaviors with the same levels of effort. So what will happen? We will change the rule in the following way. When you do some actions, you will place your tokens here. So maybe this player placed 2 actions here and 2 actions here, and this player placed the 4 actions here. Right? So what will happen is I will say to the players, you will win points according to as the same number we had the last time, depending on how many players are picking, for example, the same behavior. This is just a simple game mechanic. This happens a lot of times. So maybe you have here 3 points, 2 points, and 2 more points here. Now, what will happen is this player will learn quickly that this player with the same amount of effort actually won more points. So this player will try to optimize in the new round of the game the same behavior. And this will bring a problem in a conflict between the game. The conflict is really important because now we have a black box. This player won't know what the other player will do. So let's assume this player returns and do the same action, but now this player does the same thing. And now, as we have 2 players, the rewards are cut in half for both of them. For example, now this player will get 1 coin and this player will get 1 coin. So what will happen here is this player will know that the same strategy won't work twice. That's what the black box creates a sense of a strategy. How do you create black boxes? Black boxes are created through uncertainty principles, for example, including the actions of other players that might make this speculate that the next better move will be to do this, but it's like a rock, paper, scissors game. It has an uncertainty built around everything that's happening, so each action, the uncertainty will keep the action in the play mode, and the dopamine level will spike up and down depending on how I did on each individual round. It will not be just up and keep going down little by little. Maybe it's up this round, next round I did poorly, so it will go down and then it will go up again, and this modification of the dopamine levels will actually create more interesting scenarios. So the other thing I can do is actually create, for example, other parameters into the black box of the game mechanic, the procedure that will create the outcome. I'm talking here about rewards, but again, it's not just about rewards. This is just the case for this example. So for example, I roll these 2 dice, and now each one of these is modified by a certain number that's rolled on some dice, and these dice have some modifications depending on some status that the players have in that moment. For example, this player, if he plays on the noon or something like this player will have a better chance of getting better results in these scenarios. And maybe this player has the power of clouds. I don't know. Maybe something like if it's raining, this player will have a better chance to improve the score and lower the score of its enemies. And what we're doing here is creating actual game mechanics that will influence the way the players behave in terms of strategic optimization. And what you will see is that there will be more variability in terms of the behaviors players are doing, because doing the same behaviors will not yield the same results every time. Of course, too many players creates too many variability, and that can actually kill game design. But you need to have a black box that players feel they can control to a certain point, but that they cannot control to other certain point. Maybe this sword will be given not just by mere chance, but also through the strategic gameplay. So, for example, if a player has a lot of dominance in one of the behaviors, he will have a greater chance to win this sword than this player. And all I'm doing here is creating some variability here, some uncertainty around how I get my reward to create interesting scenarios. This is harder to design than the farming scenario. This is lazy design. This is harder. Creating black boxes is difficult. For example, in board games, you don't have actual black boxes in terms of hidden information that you don't know. Everything is known. Only the opponent's moves are really unknown, and stuff like hidden information in your cards or something like that. But in computer games, you actually can have multiple algorithms that the players don't understand how they work. For example, think of the algorithm behind how Facebook presents posts and how people are trying to figure out that uncertainty level, and that's part of the game. So you want to create this to better expose your players to better game mechanics. And that's it. This is the two-part video. Watch my video on game mechanics so you understand what I'm talking when I'm saying how this is influenced by parameters and uncertainty. And I hope this gives you an idea on how to try to better think the way you're creating these kind of scenarios. In further videos, I will try to go a bit further into the strategic choices and decision making that will actually be more about feedback than rewards, but that will be on the future. For now, I hope you enjoyed this video and it helped you think about different design scenarios that you can apply into your gamification projects. Bye!